Alright, welcome back to Mr. Pialis with Algebra 2. This is U1T3SLT13. So we're going to start off by solving some radical equations. I see what's on the outside of the radical. I need to get rid of that first. The 9 is being multiplied, so I'll do the opposite, which is divide. That gives me 10 equals the square root of 25v. The inverse operation of square root would be squared, so I'm going to square both sides next, which would give me 10 squared is 100, and square root and the squared cancel, which is just 25v. Divide both sides by 25, and the answer is 4. Over here, everything is in the radical, so I can just simply square both sides, and that's going to get rid of both of the radicals. So that leaves me with 3n plus 12 on the left side and n plus 8 on the right side. To get variables on both sides, so I'm going to subtract n from both sides. So 3n minus n is 2n. And 2n plus 12 is going to equal to 8. Next thing I would do is subtract 12 from both sides. And that's going to give me 2n equals negative 4. And then I can just simply divide both sides by 2, and that gives me n equals negative 2. Alright, so over here, I'm going to square both sides. 5 squared is 25. Square root squared is canceling itself out, so that leaves you with x plus 3. Subtract 3 from both sides, and there you go. 22 is x. Alright, so in this lesson, we're going to be exploring exponential functions. So in this case, non-integer domains with functions. So 4, it says at the end, where is it? Doubled each hour, so it goes from 4 to 8 to 16 to 32 to 64. So this was easy because these are whole integers, 1, 2, 3, 4. So we're going to leave here knowing how to do it when it's not. But before we do that, so y equals a times b to the power of x. That's the formula for exponential functions, where a is always the y-intercept, b is always the rate. So in this case, it started at 4. So the equation is 4, because that was the starting point, times the rate, which is times 2 times 2 times 2. So that's 2 to the power of x. So if you input any of these numbers of the domain in for x, you will get the answer is the output. Alright, so now what happens if the domains are not all integers? So in this case, so we're starting off with 4, and we know that after 1 hour it was 8, and then it was 16, and then it was 32. So we've already done those. So what we're really doing is we're taking 4, which is the starting point, multiplying it by something 3 times. So that's a rate 3 times. So rate times rate times a rate is rate to the third power is equal to 8. So now what I can do is I can solve for the rate, and I can figure out how much each one of these rates has to be. So I'm going to first divide both sides by 4, so that means the rate to the third power is equal to 2. And in order to get to the rate to the third power, get rid of that, I'm going to do the cubic root of both sides. So r is the cubic root of 2. Now if you put that into your graphing calculator, so remember you have to go under math and go down to number 4, cubic root of 2 equals, and it's about 1.26. So r is about 1.26. Now, if you use that rate and multiply 4 times 1.26 times 1.26 times 1.26, you should get about 8. Now, it might be slightly below, or actually above, because I actually rounded this number up, so you might actually get a number that's slightly above 8, but it should be exactly 8 if you use enough significant digits. Alright, so linear is y equals mx plus b. So this is basically just review. Quadratics are ax squared plus bx plus c, because quadratics always have x squared. And exponentials are always y equals a times b to the power of x, because exponential means x is the exponent. So we're going to now try to figure out, so what are some of the equations? I'm not going to do all of these because this is just an added bonus to what we're already trying to do in this case. So I see the pattern here is times 2 times 2 times 2, which is a geometric sequence. Geometric sequences are exponential. So that's y equals the starting point. Now the starting point here is the 0th term. If I go backwards, divide by 2, divide by 2, divide by 2, divide by 2, that would be 1. So it's really 1 times the rate, which is 2, to the power of x. For this one, these numbers are being subtracted by 16. Subtract 16, subtract 16. That's an arithmetic sequence, which means it's a linear equation. So that's y equals a rate of negative 16 per x plus the starting point. Now, if I go backwards, that's plus 16, so 66 plus 16. If I do that, that's going to give me 82. So there's the equation. If you plug in any of these x's, you should get that answer. All right, so this one, it's times negative 3 is the rule. And if I go backwards, it'd be divide by negative 3, which is 1. So the equation is going to be 1 times negative 3 to the x power. Now, this is kind of a debatable question because b is not allowed to be negative in an exponential function. So technically, this isn't really an exponential function because it's going back and forth. Negative, positive, negative, positive, negative, positive. Because when you do an exponential, it should be a hyperbola. But when you graph this, it'll just be up, down, up, down, up, down, up, down. And it's not really a hyperbola. So therefore, it's not an exponential function. All right, so this one is an exponential decay because it's multiplying by a fraction. So this is y equals a number. So where would it have started? So going backwards, times 2 would have been 320 times 1/2 to the power of x, because each number after it is half as big as the one prior to it. Anytime this rate right here is a fraction, it's exponential decay, not exponential growth. Growth would be getting bigger, decay would be getting smaller. Now, I'm going to skip through a bunch of this because I could be showing you these, but I want to just skip to the homework, which is where I do the exact same skill. So in this case, I'm trying to find, well, what number is being multiplied each time? Notice our domains are not all integers. So to get from 4 to 12, that would be times 3. So here to here is times 3. So what I do know is that 4 times a rule twice, which would be r squared, equals 12. Divide both sides by 4, and that gives you r squared equals 3. Take the square root of both sides. R is the square root, r is the square root of 3. So I'm going to put that in my calculator. Second square root of 3 is about 1.732. R is about 1.732. So I'm going to use that to multiply. So 1.732 times 4 is 6.928. Now if I multiply that again by 1.732, and that's going to give me 11.9999. So notice that it's really, really close to 12. Because once again, we had to round this. This is an irrational number. We rounded it to the nearest thousandth. I'm going to take my 12, multiply it by 1.732, and get the next one, which is 20.784. Now, I'll let you take over from here. You have a calculator yourself. Just keep multiplying by 1.732. All right, so I'm going to erase all this, do the same thing for the bottom. This time, it's the same numbers, but this time, the rate's being multiplied 3 times in order to get to 12. So 4 times a rule 3 times equals 12. Divide both sides by 4, once again gives me 3. But this time it's the cubic root of 3. So 3, the cubic root of 3. What number times itself 3 times is 3? Alright, so cubic root. So I'm going to press math. Cubic root is number 4. And of 3 is 1.442. Alright, so that's going to be the magic number that we're going to multiply by. So 4 times 1.442. Remember, that's an estimate. That's not the exact number. It's irrational. It would never end. It's kind of like pi. So that's 5.768. And then I'll do that again. Times 1.442 gives me 8.317. I'm always rounding to the nearest thousandth. That's 317. And then if you multiply that again, so that's 8.317 times 1.442, and you'll see how close it gets. It's 11.993, so we're within 7 thousandths of 12 because of our rounding. Close enough to 12. So then keep multiplying by 1.442 and going all the way across. Alright, so that seems to be it. Please give it a like if I helped you learn something about exponential equations, writing exponential equations. We also did linear equations, and we also finished the chart when it had domains that were not integers. Thanks again for watching. Have a